So here's the next video that we are going to complete to continue looking at just some of our properties for integer exponents. So we already kind of showed an application of exponents and stuff like that when it came to this folding of the piece of gold foil, but we're not just going to use our properties here to apply properties to rewrite expressions. Okay, so rewrite each expression in the form k times x to the n, where k is a real number, n is an integer, and x is a non-zero real number. So we're just going to multiply these two things together. Okay, so you can remember that multiplication, you kind of rearrange the order of the problems, and they're still going to yield the same result. So we'll put the numbers together. So we get 5 times negative 3, and then the x's together. What's 5 times negative 3? It's negative 15, right? And then x to the 5th times x to the 2. We're multiplying, so what should we do with our exponents? We should add them, so it becomes 7. And there's our answer. Okay, let's try letter B. This one's like tiny. I'm going to zoom in some more here. Okay, so there's nothing we can really do in the numerator, so we can just rewrite the numerator here. With the denominator, right, that fourth power you can distribute to both terms there, so it's 2 to the 4th, x to the 4th, which yields 2 to the 4th gives us 16, and x to the 4th. Is there any more simplification we can do? Well, yeah. We can divide those x's right there. Okay, so we can separate that and make it 3/16 times, and then x to the 5 minus 4, which will be 3/16 times x to the 1, or just x if you like. If you want to put it back in the fraction, you can. It would be 3x over 16. Either one of these, though, is fine. I think this is probably the preferred answer, though, simply because of the form we were asked for here. All right, next one. I'll stay zoomed in here. Simplifying this, again, the numerator, there's not much we can do. We'll just leave it as a 3. The denominator, though, we have a power raised to a power. So what do we do when we have a power raised to another power? To simplify, we multiply. So we get x to the negative 6. Now, recall that x to the negative 6 is the same thing as 1 over x to the 6th. So this is kind of a weird situation here where we have a fraction, right? 3 over something. Or actually, we have a fraction 1 over x to the 6th inside of another fraction. What do we do? Well, you can think about fractions as division, right? A fraction 4 halves is equivalent to 2 over 1, or just 2, right? Because it's really just 4 divided by 2 gives you the 2 here, right? Well, in a similar sense, okay, this is also division here, right? We're doing 3 divided by 1 over x to the 6th. Division can always be rewritten as multiplication. So dividing by something, dividing by 1 over x to the 6th is the same as multiplying by the reciprocal x to the 6th over 1. Or in other words, 3 times x to the 6th. And there's our answer. Okay? Let's try these here as well. Why don't you guys go ahead and try this one. Pause the video, give it a go. See what you can come up with here. They all have the same base. Okay, so hopefully you gave it a try here. There's a couple ways you could go about doing this. I'm going to do simplify the numerator first. So since we're multiplying, what are we going to do with our exponents? We will add them. So it becomes negative 3 plus 4 over x to the 8th. And then adding these together will give us x to the 1 over x to the 8th. Now we're dividing. So when we divide, what do we do with our exponents? We subtract. So it'll be x to the 1 minus 8, which is x to the negative 7. It's up to you at this point whether you want to leave it like this. Typically, though, we don't leave negative exponents, so we'll rewrite that x to the negative 7 as 1 over x to the positive 7. Okay. I'll go ahead and finish off these rest of these exercises here. So let's pause the video and you guys try these 5 exercises on your own. Okay, hopefully you pause the video here, and we'll go ahead and just rewrite these. So this one, we should get 2x to the 15th, because again, it's power times it, or you multiply the powers there, since you're multiplying the bases, add the exponents, so you get the 15 there. Okay, now for this one, there's not really anything we can do. So, but it does want, they wanted to read out as xk times x to the n, which I guess I should have done here. So this is actually the right answer for that one. Anyway, k times x to the n. So this is going to be 1/3 times 1 over x to the 8th Again, just breaking up that fraction there. And we'll have 1/3 then times x to the -8th, because that's the form that they wanted there with that. Okay, and then right in here, we can leave the 6, but then x to the -5 over x to the -3 will be x to the -5 minus -3, right? We're dividing, so we subtract those powers there. Subtracting a -3 will be adding an opposite, so adding a +3. So we really get 6x to the -2. And again, we'll stop there because that's the form that they want. All right, number 4, that 3 will distribute to both the numerator and denominator, so we get 3 to the -3 over x to the -22 to the -3. So the numerator stays at 3 to the -3, and then power to a power, we multiply. So we'll get x to the 66th, which we'll rewrite as, well, 3 to the -3 is going to be 1 over 3 to the 3rd, and this will become x to the -66 like that. And I'll go ahead and rewrite the 3 to the 3rd as 1 over 27 times x to the -66, again, from the form that they want. Last problem here, power to a power, so we simplify that by doing multiplication. This becomes x to the 2n times x to the 3. Now that we're multiplying, we're going to add our powers, and so we get x to the, now 2n plus 3, those are not like terms, so we can't combine them. So our exponent is going to be this kind of like weird binomial there. Okay, and that takes us to the end. So in lesson summary here, we have all these exponent properties, something good to review in preparation then for future lessons. So thanks guys, we'll see you next lesson.